Let's pick up where we left off with a review in our last class meeting with respect to orientation tolerances. I'm going to take us through the lecture from our last class, and remember that you can pause and rewatch any segment of this video lecture as many times as needed. If you need further clarification, please send me a message. You should also review your notes from Chapter 6, and in some cases perhaps reread sections of Chapter 6. You will also find a couple of short video links in this week's folder that highlight examples of angularity controls. Looking at this example of parallelism control, you should recall that an important component of orientation controls is that the feature control frame should always reference a datum. In this example, the parallelism control of the top surface of the part is referencing datum feature A, which is the bottom of the part. This is to say that the two identified surfaces must be parallel to each other within a tolerance zone of 0.25. Parallelism can also be applied to an axis. This example shows how the axis of a feature of size can reference a surface used as a datum feature. Notice that the tolerance zone is shown as two line elements. The axis of the whole may have tilt, or what we call attitude variation, within a tolerance zone of 0.2. In another example, we're also controlling the orientation of an axis, but notice that the datum reference is another axis, not a surface. It is important to note here that because we're referencing an axis as a datum feature, the tolerance zone is defined as a diameter, as noted in the feature control frame. Let's look at another orientation control, perpendicularity. This is a very simple part in which we want to control how perpendicular or close to 90 degrees the vertical surface is relative to the horizontal surfaces. This is a very simple part in which we want to control how perpendicular or close to 90 degrees the vertical surface is relative to the horizontal surface. Again, notice that we always need a datum identifier in the feature control frame. This is another example that conveys how a perpendicularity control may have more than one datum reference. You can see, given the illustration of the datum reference frame on the right, that the orientation control applies to the same surface, just measured relative to two distinct datum references. In other words, the identified surface must be perpendicular to each datum reference within the specified tolerance zone. That covers the high points of Chapter 6. Also find the other two short videos from last week that show examples of angularity control applied to a surface and an axis.